again. So I'll just wait for this to kick in. There it is. All right. So today we're going to start with section 2.3, and this is our first new lesson, and you guys already did this page here. So let's talk about this very first scatter plot. All you see are a bunch of dots kind of grouped together. And for me, if I were to take a highlighter, I almost see that I can take these dots and I can almost put this highlighter right there and almost get all of them inside that highlighted area. This is about the leg length and the tibia length. So your tibia length, if you see right here, your tibia is this inside shin bone right here versus the whole length of your leg right here. So is there a relationship between your tibia length and your leg length? And that's what the scatter plot is trying to prove. And the very first question says, the graph shows the plotted points rising upwards to the right. Well, I would agree. If I move to the right, like you read from left to right, yes, these points go up to the right. So for this one here, I would say agree. As the length of the tibia increases, the length of the leg increases. Well, I think that only makes sense. If your shin is growing, that means your whole leg is growing. I don't think your shin's getting bigger and bigger, and then your femur, the big thigh bone you have, is getting smaller and smaller and smaller. That doesn't make any sense to me. So as your shin is growing, your tibia, your whole leg is growing. Could you use this graph to determine the person's leg length if you knew the tibia? And that's what we're going to get to, but the answer is yes. Let's say a new student came into our class. Let's say these were all of our measurements in the class, and we had a new student come in, and the new student, we said, hey, how big's your tibia? And this person said, well, I just measured it this morning, believe it or not, and it's right here, whatever that number is, maybe 24, 25, 28, whatever. We take that and we say, okay, well, I would imagine we go up into our dots somewhere in here, and we go somewhere across and we say, hey, I would bet that your leg length is somewhere in here. It just doesn't make sense for the person's leg to be all the way up here or all the way down here. It would make sense that they're in these dots because all these dots seem to follow a pattern, okay? So all of these, I would say, are agree. We then go to the next one. And anybody following any sports right now, you probably know that Steph Curry is just absolutely on fire in the NBA with three-pointers and so on. But basically, this shows the distance from the basket and how many baskets you made. So let's say you're right close to this basket and you have 10 shots and you take 10 shots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many do you think you would sink? Well, if you're talking with me, I'd probably sink maybe 8 or 9. I'd probably miss 1 or 2, they'd bounce out, but I'd probably sink 8 or 9. I gather all those 10 basketballs and I move back to right here. This is like right between the free throw line and let's say the basket, and I take 10 shots. Now I'm probably only sinking 6 or 7. I shoot from here, maybe I'm only sinking about 4. I go to the 3-point line and maybe I only sink 2 out of my 10. And then I go to half court and I throw in like basketball or like baseballs. I take all 10 basketballs and I throw them. If I sunk 1, I'd run around the gym like I just won the Stanley Cup. But as my distance from the basket increases, as I get farther and farther away from this basket, what's happening to the number of baskets that I potentially sink? Well, it's going down. The farther I get away, the harder it is for me to sink those baskets. So let's take a look at the scatter plot. As my distance from the basket increases, the number of shots I make decreases. Do you see the difference from here? Your leg length increases. When your tibia increases, your leg length increases. But here, when your distance from the basket increases, the number of baskets decreases. So the graph shows the plotted points rising upwards to the right. No, I would disagree with this one. These are going down to the right. As the distance from the net increases, the number of baskets made decreases. That's an agree. You sink less baskets the farther away you are. Could you use this graph, or the graph can be used to determine the number of baskets you will make if you know the distance from the basket? Well, the answer to that would also be yes, because this looks kind of like a trend here. You can see these dots are pretty close together. So if we were to have this as our trend, you could say, oh, you know what? You want to take some shots in this area right here. You would say, oh, you're probably going to sink about this many. You want to shoot from way farther away. Oh, you're probably only going to sink about this many. You want to go right underneath the basket. You're going to sink probably a whole lot. But yes, we could use this to determine. okay? The very last graph you had was this, the age of a house and the price of a house. The housing market right now is crazy. People are buying houses for way more than what they're worth. But unlike these two, do you see the pattern going up to the right and the pattern going down to the right? Nice dots are tight together. Notice this one here. If I were to try to draw a line through them, I would say, well, no, I can't do that. Maybe up this, no, that doesn't, oh man, I don't know what to do because look at these things. They're all scattered all over the place. So when you take a look at this, the graph shows a plot of points scattered, agreed. As the age of the house increases, the price of the house increases? No, not necessarily. Like take a look, as we get older and older and older, you got some houses that are worth a whole lot of money. People are putting money into them, they're doing their landscaping, they're putting a pool in, they're upgrading, or you let, some people are just kind of letting the house go and kind of rot away. So as the age of the house increases, the price automatically increases? No, that's a disagree. And the graph can be used to determine the price of the house if you know the age. Well, if you told me your price of your house or your age of your house is right here, I don't think I could tell you what the price is because it could be right here, or it could be right here, or it could be right here. But because these are all spread out, the answer to this one is disagree. Okay. Can you guys put your hands down if you understand that warm up? Just an intro to scatter plots, just kind of the graph and just kind of getting going on what we're going to do now. Okay. All right, so let's now move to this page right here. So we're going to get just a little bit of practice on graphing, okay? And yes, we're going to get a little practice on graphing here. So this is all about the wingspan and the data for 18 birds, okay? So you see the first column is the length in centimeters. The second one is the wing spread or the wingspan of these birds. So how tall is the bird? And when it opens up its wings to its full kind of wing spread, how big is the wing spread? Notice the very first column. We're going to learn this today on the next page, but notice the very first column always goes on the bottom. So length goes on the bottom, and notice the wing spread goes on the side. If we were to title this thing, there is no title here, but we're going to learn it, so I might as well just show you. It's always the second variable, the wing spread, versus the first one, which is the length. So the yellow, which is your length, always goes on the bottom and always is second in your title. But the second one in your table, in this case, it's the wing spread, always goes on the side, but it's actually the first in the title. So you're going to see this pattern all the time. The first one in your table always goes on the bottom. It's the last one in your title. The second one in your table always goes on the side, but it's the first one in your title. And now we're just going to get some practice plotting points just to make sure that you remember how to do this part. So the very first bird has a height of 12 and a wing spread of 35. So if we find 12, 12 is really close to the 15, somewhere in here, and 35 is up just past the 30, somewhere right in there. Do I know for sure that's where it is? Not really, but it's really, really close. Like, I don't know if it's exactly 12 and exactly 35, but that's in the general area of where this point should be. The first one's done. The next one's 120, all the way down to 120. First length of 120, all the way up to 300. There's your next one. Done. You guys continue to plot all of these points, and I'll just kind of go slow myself, but you guys get practice plotting these points, okay? So 75, and then all the way up to 250, which is just past 240, because the next line's 270, so you got to figure there's 250, 260, 270, so I'm kind of close to the bottom, somewhere in there. 78 and 222, maybe somewhere in there. And you guys just finish, okay? This one here, don't be worried that this 124 is a little bit past the 120. If we were to keep this going, 124 would just be a little bit past, all the way up to 157, somewhere in there. That's fine.
We don't have that page, do we, sir?
You guys don't have this page?
I don't.
I do. It's on the back of the.
It's on. It should be on the back of the one you just worked on.
Oh, okay. Okay, I do. Sorry.
You scared me there for a second. And when you get done, just put your hand in the air for me, okay? I'll know you're done, but you should get something that kind of looks like that. It might not be exact, like every dot might not be exactly where my dot is, but you just got to get pretty much that area. This is a little more difficult to get exact numbers because there's a lot of numbers between 0 and 15 and 15 and 30. So you've got to kind of approximate where your number would fit in there. Just like you would on the side, they're going up by 30. So you just kind of got to get an approximation at where it should go, but the general pattern should be the same, okay? That general pattern should be the same. So when you get done plotting all those sets of dots, just put your hand in the air, and I know you're done and we'll move on, but I'll give you time to plot here. Perfect. I see people starting to finish up there with their hands in the air. Just take your time. I'm not rushing you. We've got time today. Excellent. Just a few more people here. Okay, so once you're done, put your hand in the air. I know I can move on. This is my way of being able to tell, okay, when people are done. If I was in class, I could see when people stop writing, and I can see when somebody's finishing up those last couple dots as I'm walking around the room. It's a lot easier when it's in person. But when we're at home here, I have a hard time telling when it's time to move on. So You guys have to be doing what you're supposed to be doing and make sure you're not distracted, because if you take time right now to go on your phone for a bit and start texting your friends or to leave and come back and your hands on the air, we're waiting on you. So that's kind of what I'm implying here. So I have no problem giving time to finish, but just make sure you're doing what you're supposed to be doing, okay? So a few more people here. And as those people are finishing up, perfect. We got a couple more left. So just as those people are finishing up, let's just answer these two questions at the bottom. Okay, so this is from the University of Waterloo. This was data from Waterloo. And here's the very first question. Describe the pattern of dots. Okay, describe the pattern of the dots in your scatter plot. Well, when I take a look at these, does this look more like the tibia length and the leg length where the dots go up to the right? Does this look more like the distance from the basket and the number of shots you made where they go down to the right? Or does this look more like the age of a house and the price of a house where the dots are everywhere? Well, I think for sure you know that it doesn't go down to the right. I think you know it's definitely not like the basketball net one. But I also don't think it's the house, because I do think there's a pattern here. I do think even though the dots are spread out a little bit, do you see how we don't have dots everywhere here? Like this? We actually do have somewhat of a pattern. And for the most part, do you see with a highlighter how these dots are typically kind of going up to the right? Yeah, there's a couple kind of sticking out here and a couple sticking out here. But when we go through the most part, do you see how we kind of have these dots going up to the right? Right there. Like that's a pretty good pattern. Like they do go up to the right, and it does make sense because the bigger the bird, wouldn't you think the bigger the wingspan? Like as the bird gets bigger and bigger, wouldn't you think like their arms, their wings would get bigger and bigger? I think that makes sense. This point right here is kind of sticking out by itself. We'll get to that type of a point later on. This is kind of a special point here. But for the most part, yeah, the dots go up to the right. So that's what we're going to say right here. Describe the pattern of the dots. The dots seem to be rising to the right. So whenever you see dots or data, dots or even the word data, describe the data, they both start with D and they're both 4 letters long. Data, dots, data, dots. Just tell me what the dots are doing. The dots are rising to the right. And actually, take a look here. I had them hidden. Sometimes I outsmart myself. Do you see that? The dots rise to the right. But then when we go to the bottom, describe the relationship. Well, this is a little different between the bird's length and the wingspan. Length and the wingspan. Whenever it says describe the relationship between the two variables, do you see the bird length right here and the wingspan? You always start off by this one increasing. When the bottom one increases, automatic, what happens to the side one? Does it increase? Does it decrease? Or is there no relation? If I were to go back, does the side one increase? Does it decrease? Or is there no relation? And in this particular case, we always start off by saying, as the bottom variable, here, so as the bird's length, how tall the bird is, increases. It's always, always, always as the first one, the bottom one increases. As the bird's length increases, as your tibia length increases, as the distance from the basket increases, as the age of the house increases, it's always that bottom one, the first one in your table, increasing. Then you decide what's going on with the second one. The wingspan, so increases in this case. But you could say increases, decreases, or there's no relation. So for this one here, as the bird's length increases, the wingspan increases. If I were to go back a page, as the tibia length increases, the leg length increases. As the distance from the basket increases, the number of baskets made decreases. As the age of the house increases, there is no relation to the price of the house. So it's always as the bottom increases, what happens to the side. Okay, so when you get that copied out, put your hand down for me. When you're all done that next page with the bird length and the wingspan, when you're all done that one, put your hand down. Awesome. Hands are firing down at a rapid pace. As the number of students who finish this handout increases, the number of hands in the air decreases. That is a negative relation. Take a look at that. As the number of students who finish this work page increases, the number of hands in the air decreases. That would be a negative correlation, which we're going to get to. So a couple more people here. Brooklyn and Sawyer, you guys good? Awesome. Brooklyn, you're all good? Excellent. Okay, let's go to the next page. And this is where you guys are going to copy out a few things for me. Okay, we're going to go through this together. This page is called a wipe away. I've been using a smartboard for a long time now, and I've got a lot of little tricks and stuff that I can do. And this is one of my wipe aways. So a scatter plot is a graph that shows the relationship between two variables. So on your page, please copy out exactly what we're doing here, relationship, okay? So a scatter plot is just a picture of a table. That's all the scatter plot is. And it's always two variables, never three, never four. Think about the two variables. Tibia length and leg length, two variables. Distance from the basket, the number of baskets made, two variables. Age of the house, price of the house, length of the bird, wingspan of the bird. It's always two variables. They often show a pattern. And when something's a pattern and it happens over and over and over and over and over again, it becomes a trend. Okay? So a pattern or a trend. If one of you always consistently logs in late to these meetings, they're always 15 minutes late, that becomes a trend. Okay, if somebody's always online a little bit early just to chit chat, that becomes a trend. And from your pattern or trend, you can describe the relationship, okay? So I don't know if anybody had parents like mine, but my mom used to, you know, every birthday, we used to get up against the closet kind of frame, and she would have all these little pencil marks of how tall we were as we got older and older. We always got measured on our birthdays. This is exactly what's happening to Julie. Julie gathered information about her age and her height from the markings on a wall in her house. So her parents did the same thing. So what this table is comparing is these two variables, age and height of Julie. When she was 1, her height was 70. When she was 2, her height was 82. 3 was 93, 4 was 98, and so on and so on. And this seems to make sense because as her age is increasing, her height is also increasing. It makes sense to me that as she gets older and older and older, her height's going to increase, okay? So it says, draw a scatter plot. Well, this is our very first one that we're going to do together. Notice the very first thing we have to do is label the bottom, label the side. The first variable in your table, whether it's a horizontal table or a vertical table, it doesn't matter. That first variable always goes on the bottom. So you see age in years, age goes on the bottom. Thought I had it there. So let's write that in. Age in years. And what's on the side? It's your second variable, which is your height in centimeters, or Julie's height in centimeters. So I'll just kind of turn that on the side, and I'll put that right here. First variable, always on the bottom. Second variable, always on the side. You never pick. You never decide, today I want to put the first one on the side. It's always bottom, first one, side, second one. The title, though, is a little bit weird because it's the second one versus the first one. So our title in this case is going to be height versus age. And now we have our table set up in order to make our scales. Do you see how there's no numbers here and no numbers here? When we just did the one with the bird, the numbers were already there, but now we've got to create these. So let's take a look at the numbers for her age. What numbers do we have to get onto this thing? It's the numbers from 1 to 8. Well, I almost feel like we could probably just go up by ones. If we start at 0, always start at 0 the first line, 0, 1, 2, 3, 4, 5, 6, 7, 8. I like that. So let's start at 0, and let's just start to increase every line's worth 1. But if you guys are okay with this, even though this line is 1 right here, I'm not going to write it. I'm just going to go to the second line. I'm going to put 2. You can put a 1 here if you want. Okay, if you want, it's up to you. But I'm just going to maybe say, I don't need to put a 1 there. I know that's a 1. The next one's a 2. I know this is 3. The next one's 4. Skip a line 6. And it makes your scale a little bit more neat, I would say, if you space out your numbers a bit. Okay. But as long as you can skip count, as long as you don't get confused with what the lines are, especially when you get to bigger numbers, that's the key. Okay, well, I don't want to undo that one. I don't want to undo the other one. Let's just get rid of that. Perfect. Okay. Now, just be careful. The problem on the side is we don't want to start at 0 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because those aren't the numbers for the height. Take a look at the height. The height goes all the way up to 135. We start at 70. So I'm not going to worry about breaking an axis just yet. I know some of you are maybe thinking that. But what do I go up by every single line in order to get up to 135 up here somewhere? Well, let's try tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Not going to work. Let's try 20s. 20, 40, 60, 81, 20, 40. That would work. Maybe 15s. 15, 30, 45, 60, 75, 90, 105, 120, 135. That seems to be a really good number to go up by. Let's go up by 15s. But I'm not going to label every line 15. I'll start at 0. And I know my scale is 15. Every line is going up by 15, but I don't need to label every line. I'm going to skip to 15. I'll just write 30. Don't write 15 here. I'll just write 30. You could write 15. You just don't have to. The next one would be 45, but I'm not going to write it. I'm going to put 60. Then I'm going to put 90. Every 2 lines is going to be worth 30, which means the scale is actually 15. Okay. Now, if you're a little bit going to be confused, then please put 15 in here. You can. You can put 45 in here if it's going to help. You can put 75 if it's going to help in this case. It's not wrong. 105. But you technically don't have to write every line if you don't want. That's all I want to say. Okay. And 135. I'll just write in 130. Okay. So now you are all set up in order to graph this thing. Let's start to graph our points. 1 and 30. Sorry, 1 and 70. And my daughter is here to let everybody know that it is snowing outside. Right, Cassidy? Yes, we've got snow outside, everybody. So here's 75. So right before, just picture 60. If we were to break this into 5s, 65, 70, 75. So if we were to break it into thirds, we're right up in here somewhere. There's 1 and 70. First point's done. 2 and 82. Well, here's 75. Here's 90. 82 would be somewhere right in between. Done. 3 and 93. 90 just above. 93 would be somewhere in there. 98 would be somewhere in there. 106, I'm just moving over a line every time. 118 is almost to 120. 127, about halfway. And then 135 exact. Okay. So you guys plot those points there. And when you get done plotting all those points and you've got this scatter plot all done looking like mine, put your hand in the air. If you have any questions, feel free to ask, okay? Just because I'm doing a lot of talking today doesn't mean you don't, you're not able to ask a question. If you have a question, please let me know. Okay, so once you're done, hand in the air. Still got a couple people that need to sign up for Remind Text, okay? If by chance you haven't signed up and you prefer to get emails, like get an email notification, just let me know. Send me a message in Edsby and I'll tell you how to sign up for an email instead of a text message, okay? Okay, so we got a few more people. All right, so we got about 4 or 5 more people here. Okay, so Olivia, Andrew, and Hayden, just let me know when you guys are done. Okay, as the last couple people are finishing up, let's take a look at these questions. The first one is describe the trend in data. There's a difference between describe the trend in data and describe the relationship. Data, dots, data, dots, data, 4-letter word starting with D, dots, 4-letter word starting with D. You want to tell me what's happening to the dots. And in this case, the dots rise to the right. They go up to the right. This is like your tibia in your leg length. This is not like the basketball question. This is not like the age of the price of the house. So whenever you see data, 4-letter word starting with D, it's dots. Tell me about the dots. 4-letter word starting with D. That's how I used to remember it. Okay. Now describe the relationship. There's only really 1 or 2 words that ever change. You use the 2 variable names, and it's always as this bottom variable increases. As Julie's age increases. That's standard. It's always as the bottom one increases. What's happening to the side one? Is her height increasing? Is her height decreasing? Or is there no relationship? And in this case, as her age increases, her height increases. If the dots went down to the right, boom, 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 it wouldn't make sense. But as her age increases, her height decreases. If her points were all over the place, as her age increases, there is no relation with her height, okay? But in this case, there's a pretty good relationship that as her age increases, her height increases, okay? Now, these 2 variables, located here and located here, located here, located here, located here and here, they always have this pattern. The first one in your table is always on the bottom and is always the second one in your title versus the second one in your table, and I'll do green here, the second one in your table is always the side one in your graph and the first one in your table. So that's always the pattern. The first one goes on the bottom and it's second in your title. The second one always goes on the side, but it's first in your title. Well, this yellow one, this first one, is called your independent variable. The independent variable is located on the horizontal axis. Horizontal axis is the one like the horizon. Okay, if you ever had a sun like a horizon, there's your sun. Do you see the horizon is always horizontal? So the horizon goes across. That's your independent variable on the horizontal axis. It says this variable does not depend on the other. It means that her height depends on her age, okay? But the dependent variable is located on the vertical axis. If you're ever in gym class, the vertical is straight up and down. A basketball player usually has a very good vertical jump because they got to be able to jump high to get the rebounds. So most basketball players have a very good vertical jump, straight up and down, vertical axis. So in our particular case, the independent variable was her age and the dependent variable was her height. And please note that the independent variable comes first in a table of values. Now, I know you don't have this on your note, the two little tables, but you can just kind of draw that in. When you get that done, put your hand down for me, okay? Perfect. Okay, most people done. About half done here, okay? So once you're done, put your hand down. We're almost ready to get you guys working here. Okay, 7 more people. So the first variable in your table is the independent variable. It always goes on the bottom. You don't ever choose, it always goes on the bottom. The second variable in your table is called the dependent variable, and it always goes on the side. But then your table or your title of your scatter plot is always the side variable versus the bottom variable, okay? So Amelia, Kaylee, Zach, Eric, Olivia, Keegan, when you guys are done, let me know, okay? So we can move on here. Hand down when you are done. All right, so we are good to go. Let's turn the page. We're going to do this together, okay? This is the life of the farmer. The following table shows the height of corn in a farmer's field over a 6-week span. So you see the table, length of time in weeks, and the height of the corn. 0, 1, 2, 3, all the way to 6. You see the height of the corn. And the very first thing is label each axis with the correct variable. Can somebody on mic tell me what goes on the very bottom of this table?
Length of time.
Perfect, right? Length of time goes on the bottom, which means what goes on the side?
Height of corn.
Height of corn, perfect, right? Now somebody knew, what's the title of this scatter plot then? Length of time goes on the bottom, height of corn goes on the side. Somebody knew, on mic, let me know what the title of the scatter plot would be.
Length of
Height of
time versus height of corn.
Oh, say that one more time.
Length of time versus height of corn.
That is,
Oh wait, no. Height of corn versus length of time.
that is correct. I knew you were gonna fix it. That is correct. It's always the side versus the bottom. So here's what I have, and you guys can also do. Okay, length of time goes on the bottom, height of corn goes on the side, and you've got your title. You guys can fill that in. Now, let's take a look at the bottom. We need to fit these numbers right here, 0, 1, 2, 3, 4, 5, and 6. We need to fit them onto the bottom. What would be a good scale to go up by? When I say what would be a good scale to go up by, I want the number that we're going to make every single line worth. Is every line worth 1 or 2 or 10 or 50 or 100? What is every line going to be worth? Anybody want to unmic and let me know what the scale on the bottom should be? You know, is that Kaylee that just unmiked? Was that Kaylee? Because 1 is exactly what I put the first time I did this, and I realized I made a small mistake. Okay, I realized I made a small mistake. So the bottom scale, when you say 1, don't write this, okay, everybody? Don't write this. But you see here how if I make it 1, and I believe that was Kelly, and I did the same thing, okay, Kelly? If I went 0, and if I had a scale of 1, take a look. 1, 2, 3, 4, 5, 6. Do you see how all my numbers are going to be, or all my dots are going to be on this side of this line? I've wasted all this side of the graph. Do you see that? So our scale isn't going to be 1 where we're going to make every single line worth 1 as soon as we go to the next line, we add 1. What should our scale be instead?
.5.
Absolutely. Let's go up by a half. Do you see how we're going to have a scale of a half, which means every other line is worth 1. So we're going to label every other line worth 1, which means our scale is a half. Every line's worth a half. Does that make sense, everybody? Kaylee, give me a hand in the air if you understand that, okay? Perfect. So every other line is going to be worth 1, which means my bottom scale is worth a half. That's how you refer to the scale. Okay, now let's take a look at the side scale. Take a look at these numbers I have to fit, 0, 5, 18, 29, 45. Please don't just write these numbers onto lines. Don't just put 0 here and then skip a line and go 5 and skip another line and go 18 and then skip another line and go 29. You're not going up by the same amount every time. This is not a scale. You want what you're going to go up by every single time in order to get the number 70 somewhere near the top. What's that scale? Somebody knew. What would be the scale on the side? What was that, Carter?
5.
I agree. Make every line worth 5. But Carter, do I have to label every line? Do I have to put the numbers on every single line?
No, you could skip one and just go up by 10.
That's exactly right. So when you look at this, you may look and say, hey, the scale is 10, but it's not. The scale is 5. I just labeled every other line, okay? Once you get those two scales done, plot your 7 points onto this graph. And then I want you to answer the 5 questions down below, okay? I'm going to give you 10 minutes to work on this. I'm going to take this up and then I'm going to get you working on a little bit of homework, okay? So I'm going to put 10 minutes up here. And I'll start to take this up in 10 minutes, okay? I'm going to stay online. If you have a question, please ask me. But I'm going to give you 10 minutes to finish the scatter plot and answer those questions, fill in the blanks. Actually, just give me 1 second. I'll be back in 1 minute here. Just going to check on my daughter.
You already have nail polish on your nail. But when I take my nails,
So I'm just going to kind of slowly go through this as you guys are working, okay? When I plot my points, I end up with something that looks like this.
he actually tore it off a paper towel. Are you nice? You can shave her. She's nice.
Okay, so if you quickly just want to check your scatter plot here, just that you got something that looks like that, I would imagine most of you do. Okay, so label each axis, we did. The independent variable, if I remember back from the previous page, the independent variable in this case is the first one in my table or the bottom one on the graph. They're the same. So I believe that's going to be length of time. And this is located on which axes? Horizontal, horizon. The bottom one is horizontal axis. Which means the dependent variable, what depends on the length of time? What variable depends on the length of time? It's the height of the corn. The height of the corn depends on how long the corn has been in the ground. This is located on the vertical axis, the one straight up and down. Think of a vertical jump, straight up and down. Make a scatter plot, we already did. Finish the statement. As the number of weeks increases, the height of the corn blank. It's either increases, it either decreases, or there's no relation. And when I take a look here up top, as the length of time increases, the height of the corn also increases. That makes sense, it's growing, also increases. Okay. Now, hopefully everybody's good up till there. I gave you probably a little more time than what you needed. We still got about 3 minutes left, but I think I gave you a little more time than what you needed. But I want to have a little discussion about this here. Can you type off to the side right now under the chat? Can you just type yes or no? If the corn did not change for 4 weeks, okay? Let's just pretend that this corn did not change height. It stayed the exact same height for 4 weeks. Would you be worried, or should this farmer be worried? Can you type yes or no off to the side with how you think you would answer this? Overwhelming amount of yeses. I don't see anybody with a no. I don't see anybody with a no. Except me. I put no. So I'm going to play devil's advocate here. Okay. Most of you are saying yes. Can somebody tell me why the farmer should be worried if the corn hasn't grown in a month, 4 weeks? Can somebody tell me?
Because if it's not growing, it could mean that it's dead.
Absolutely. If it's not growing, Claire, it like that, there's something wrong. There's either a disease, something isn't right if that corn isn't growing. And I would agree 100%. Okay. So I would agree. And I think most people would put yes. And as long as you gave me a reason, do you see this right here? This is where you guys lose little marks all the time. And I say you just in general, grade 9, you don't explain. So if you said yes, and you said, if the corn isn't growing, then the cobs aren't going to be growing or the corn's dead, or just give me a reason and you get full marks. Just give me a reason why. But now I'm going to play devil's advocate. And believe it or not, I do farm and I do grow corn. And believe it or not, there would be a time where I wouldn't be that worried. If it didn't grow for 4 weeks, I would not be worried. I could argue that no, I wouldn't be worried. Can somebody want to tell me why? Maybe now that I've said that, it sparked something and you might have said, hey, wait a second. Why maybe I shouldn't be worried if it hasn't grown?
Maybe because it's either winter or you could just not have corn planted at the time.
Okay, it could be winter. Maybe no corn was planted. Let's assume that it is planted. I did plant corn, and let's just assume that it's not like in the middle of winter. Keegan said it might be at its full growth. I like that. Anybody else?
It could be ready to harvest.
That's exactly it, Claire. So when corn grows, here's what happens, okay? And let's just pretend that this line is corn right here. So you plant corn in the ground and it starts to grow and it starts to grow and it's getting taller and it's getting taller and it's getting taller and it's getting taller. And then all of a sudden, your corn is at its maximum height. And here's the ear that you're trying to harvest, that cob of corn right over here. Come on, I wish I could do that a little easier here. So here's the cob of corn. What is going on here? Anyways, there's your cob of corn off to the side, and it gets to its maximum height. And Claire just said, maybe it's time to harvest. What happens with corn? When you're driving around, watch this. Corn's going to be growing. It's going to be nice and green and really, really kind of lush color. And then all of a sudden it gets to its maximum height, and the farmer doesn't combine it right away. It doesn't take it out of the field. They wait. And it dries down, and all of a sudden this nice green looking corn starts to turn yellow and brown, and it starts to die off. The cob is okay, but the plant doesn't grow anymore, and all that energy goes into the cob. So if it's at the end of the cycle, if it's at the end when it's got its full height, I wouldn't be worried whatsoever. Like when it comes to, September, I wouldn't be worried at all if it didn't grow anymore and I just waited till October in order to harvest it. That would be fine. But in the middle of June or July, this is like only a foot or two out of the ground and it's not growing for a month. Yes, I would be worried. So the answer to this question, you could say yes or no. Just give me a reason why. I would expect most of you would have said yes on a quiz or a test, and you would have said there's something wrong with the corn. I would have given you full marks. If somebody would have said no, if it's at the end, no, you don't have to worry. Just wait for it to dry down. I would have given you full marks. Okay? Is everybody good there? Excellent. I am going to stop the recording because here's what we're going to